be here with my colleague and friend, John. How are you, John?
I'm good, Francesco. It's good to be here. And hello, everyone joining us from around the world.
Quick question to, defrost the ice. Is it Arsenal going to win the league this year?
Wow, we don't talk about that, mate. Like, it's a bit like Fight Club. Let's just see what happens, hope as much as we can that it happens. And yeah, I'm not talking about it.
Perfect. So unlike John, I believe today what we will talk is about predictions. And predictions and AI, generative AI, you call it. It's all about predicting. Generative AI is, at the end of the day, a tool that allows you to predict the next word. And it's so good at predicting the next word that it can produce, text, songs, images, and everything else. So what we are going to do today is check what you can do already with generative AI with all the lovely toolset that you have been using and deploying on a daily basis. So I want to welcome everybody in this webinar today. I'm Francesco, CTO of Ivan from Italy, and then we have John.
Hello, my name is John Kennedy, head of databases here at Ivan. I'm based in the UK.
So please let us know where you're coming from and if you think that Arsenal will win the league next year. So talking about more complex things, let's start with our talk about databases, vector databases, generative AI. And let's start by touching the subject of vector database and where we are now. Before understanding vector databases, let's give a short intro to what are vector and vector databases. Because if you go down in the definition on how generative AI, how a lot of AI works, it works by basically comparing vectors, which are a set of coordinates in a huge space. Everything that tools like ChatGPT or Gemini or Vertex or a lot of the Mistral models are doing is just condensing a lot of information into a vector. And they do this so well that vectors with similar meanings occupy a space, a portion of the space that is close to each other. Like you can see in the picture here, the vector for dog and wolf are really close to each other because they represent an information that is really close to each other. Basically, everything that OpenAI and all the other tools, all LLMs are doing is creating embeddings, so creating these vector representations of informations. And then when you query, when you ask something to an LLM, they will create a vector search. They will search in the space of their knowledge what are the data points that are closer to the query that you are asking. And with that information, they will create the reply. So how they do this is basically they use vector database in the backend to store this enormous string of information. And there can be models with billions of parameters or thousands of parameters, or you can have a small model with hundreds or tens of parameters. But you will store this information in a vector database. And every time you query for a specific, when is Arsenal going to win the league, it will create the embedding, the representation in the vector space, and then find all the pieces that are close to the vector in question. So this is the intro to vector database and vectors. Let's pass the ball to John about, do you really need a dedicated vector database?
Yeah, thanks, Francesco. And so we're here today to talk about how companies and decision makers are deciding whether they need a dedicated vector database or whether they can get by without one. So the context here is that we see, and I see a lot of our customers, they're learning about AI. I'm sure your organizations are too, whether that's GenAI or other less ML workflows that just leverage AI or were previously called AI. And so they're trying to learn it. They're trying to gain the knowledge internally. They're trying to get started. And the best way that most companies are going about this is they're picking up and trying to build something. They're learning by doing. So that's great. So there's a lot of content out there. By the way, the slides you're going to be looking at are not, they're not data pipelines. They're not architecture diagrams. They're simple so that we can talk about the decision-making process and why rather than, so if you're looking for technical diagrams, this is not the webinar for you.
But you can ask us and we will be more than happy to go through all those details.
Yes, we can give you that afterwards. So you're a company, you're trying to get your hands around AI, you're trying to get your hands around GenAI. You know that you need a vector database because it's key to nearly all GenAI workflows. So your decision comes to this: do I need to buy and get a dedicated vector database in, or no? So here you've got just a very simplified diagram that shows, as Francesco discussed previously, an app making a query. That query then gets vectorized into the database, the vector database. It's then there's a nearest neighbor search for other vectors around that area to provide you the answers you need. So this might be like show me X or Y, or things that are like Z, or those kind of things. And if you've got a separate database, as in here, you've got an additional step between the actual data that's not vectorized and the vectorized version of it in the vector database. There are a number of steps in and around various workflows you can have here that are, whether you're doing the embeddings and storing back, or referencing, or pulling new data, or a RAG flow where you're updating the vector database with new stuff that's arrived in the database. When these things are separate, getting the data to and from is it's not a complicated task. There are many flows, but it takes time. It takes time, and you're going to be transferring data around. Now, for a business, that's two things. One, you've got risk. There's a step that can go wrong. Two, it could be costly depending on where those data sources in your vector database is. Given those additional steps in the process, getting it to be real time is going to be tricky. It's not impossible, but you're going to have to do a lot of work in your infrastructure to have this separate database alongside your database where the content is, to make sure that it's all working well. But the main barrier to entry that we've seen of having a dedicated vector database is about your company. And this is about the people you're giving this challenge to. You're asking them, go and investigate AI for me. How does it work for our company? What do we need to do to get it working to deliver value for our customers? Now, if they're picking up a brand new database, developers are massively capable. They will learn anything you give to them. But if your goal is to validate quickly whether your company can get a useful outcome out of AI, you need them to have as few barriers to getting started as they can. You need as little friction. And when you hand them a brand new technology like a new vector database, yeah, they're kind of like just a database, but they fundamentally aren't. So those people are going to have to learn that new database. They may need to learn slightly different languages, and that's not a trivial piece of work. You want to get started as quick as possible. You want to avoid having a massive learning curve for a new technology. Secondarily, vector databases. I've been in the database space a long time. A niche database that comes out new is usually really good at the one thing it's trying to solve in the niche. But enterprises and companies need all the rest. A database that's been around 10, 15, 20 years is going to be hardened. It will have features that you just rely on without even realizing that they're there. And when you have a niche database that's new and young, it won't necessarily have those capabilities. So you're going to be pairing up a immature technology that's moving fast but won't meet your enterprise needs with your current enterprise stack. That's going to cause you some challenges. That will also feed into security and high availability. These younger databases, very good at specific things, not as hardened, not as enterprise ready. That's just time. All the larger, more mature databases do. But the great news is, in that same way, with those mature databases that already have the enterprise capabilities, it's actually relatively easy for them to pick up these new niche capabilities as they go along. So what we're seeing as a trend in the market is all the mature, I don't like the term legacy because it's not legacy, all the well-adopted technologies are now picking up vector capabilities that meet the needs of 80 to 90% of the workloads you're going to be looking at. So that's why when I'm talking to our customers, when they do a tech bake-off with all the technologies we have in the platform that have vector capabilities internal to them and a standalone vector database, more often than not, they're picking the technologies they already know. and it's got a lot of massive advantages for you as a company. So let's talk through a few of those. So first, as we discussed previously, if it's all in the same database, if you've got a vector capability within, say, Postgres, for example, the data isn't going to be moving in and out between two different databases. That's great. The second thing, as I discussed previously, you want a really low friction way to get started. So your engineers can just go concentrate on understanding how to get value out of AI, not how to use a new vector database. So they don't have to pick any new tools up. They're already in databases they're really familiar with. These are really well-known and adopted things like PG. So, and it's already maintained, as it says here. You've got someone already looking after this database. You don't have to try and give a team in your internal org another database to look after, which causes them more toil. So there are loads of organizational value points. The other thing is it's consistent. You know what you're getting at, and you're able to develop hybrid search technologies. So for that reason, and given our customer feedback, that's why we believe if you're getting started with AI and GenAI, the quickest way to value for you is going to be to choose vector capabilities in the databases you've already got. So what databases that already exist have vector capabilities? That is a great question. So the good news is, as I said, a lot of the databases who have been out for a while have very quickly been able to bring these capabilities in. And you're looking at 4 of them here that are present in the Ivan platform. Ivan for OpenSearch, Ivan for PostgreSQL, Ivan for ClickHouse, and Ivan for Dragonfly. Now, which one you choose depends on you as an organization for the points we discussed easily, but we'll go into that in a minute. The reason you want to pick a database you're already familiar with is for a number of reasons. Performance. You're getting started. Even after 1 to 2 years of developing AI capabilities, you still won't run to the limits of the vector capabilities within those databases. You don't need a Formula One car at this point. You're not going to be getting there. So a dedicated vector database is not necessary for your performance levels.
Just one thing, performance are there also with standard databases, well, with traditional databases. There are a number of performance optimization that you can do on top of vector and not vector data that are there for any use cases. So don't think about, okay, I'm using a traditional database, I need to give up performance. That's not the case. And they will add more and more performance over the years.
Yeah. The other thing we haven't really touched on here is those products are widely adopted. They have a super engaged community that are always continuing to develop and improve and develop and improve. And that becomes from their maturity. Those technologies are loved. They're going to keep advancing. So performance on a number of axes is going to continue to be of high levels. As we mentioned before, really fast onboarding. You ask someone on your developers to use a technology they're already familiar with. You've already knocked the knowledge learning and the learning curve right out the window. So you're going to be able to get ROI from your development effort in a shorter space of time, which is critical. As we've mentioned, it's a mature technology. It's already got the security built in. These things are battle hardened for enterprise environments. And you're not going to be adding another database and therefore making your architecture and infrastructure more complex. And you won't have to go and beg your SRE team to pick up a new service to monitor. All those things are the reasons we've heard from our customers that they are picking vector capabilities in the databases that they already know.
The last piece is you may want to deploy a vector capabilities where your data is ready. So your data might be in any of the cloud, in none of the cloud, or in you may need to use your vector database or store your vectors close to where your AI models are. Having the portability that allows you to just deploy vector capabilities everywhere with this open source tools is just, next level.
Yeah, that's a great point. Yeah, totally agree. Well, let's have a quick talk. Now, one of the things you'll have picked up there is you're going to need to you will ask your engineers. I suggest you do a technical bake-off. Get before you kick off your AI project or your investigation, get your engineers to take a look at the various vector capabilities within these offerings, and then against probably a dedicated run, because it'll be critical. And you'll probably realize that your engineers are likely to pick the tech they already know. So there's going to be a bias, and that's okay. Here's some of the reasons and some of the differences how these databases operate differently generally, and then specifically for vectors. So Postgres, known, loved throughout the world. It's great. It's got great performance at scale. The pgvector extension, which gives you most of the capabilities, is super performant. It's evolving at a rapid rate, and we're seeing great adoption levels internally for us and in the wider community. Those vector indexes, which come with the extension, are hard to beat at the moment. You also get advanced features within the Postgres database relating to hybrid queries that mean you're going to be able to do a bit of vector and a bit of relational, transactional queries in the same database. And to do that is really powerful. So again, doing the vectors where the workload is in your PG database, super high value. Ivan for ClickHouse, newer technology. However, the power of its engine means that it is fundamentally brilliant at a lot of things. Vector database, vector capabilities are one of them. One of its great values is it horizontally scales brilliantly. It's got a columnar format for super fast analytics. And if you combine an analytics workload and vector capabilities, ClickHouse is the service for you. The parallelized query pipeline is where the power comes from. And on Ivan's offering, we're just launching tiered storage. So that longer tail of data that you need to store that you maybe don't query so much, you can do that in a really cost-effective way. So horizontal scaling, cost-effective storage for older data, analytics with vector, ClickHouse is your option. So Ivan for OpenSearch. This is the open source version of Elasticsearch. Let's not talk about license changes here. Again, horizontally scalable, works really well with a large range of text functionalities. Hybrid search is a superpower of this service. And what we've heard from our customers is your ability to tune and alter search algorithms, vector algorithms within OpenSearch is really good. So if your use case where it needs this kind of tuning and tweaking rather than the more generic approach, this is probably going to be something you'll want to look at, and make sure you chat to your teams that they poke at this aspect, because it could be the deciding factor. We've seen it's been the deciding factor for a number of people. So make sure you have a look at this, because again, it reduces your friction, but also make sure that you've got a bit of range on what you can do with it before you have to go into too deep additional knowledge. So that's OpenSearch. And finally, Ivan for Dragonfly. This is an in-memory database, key value pairs. The power of that kind of in-memory speed is hard to match, and it's brilliant for really fast vector search. Caching of data and embedding. So when you want to, as we mentioned earlier, some flows require you need to go and create the embeddings of your data, and that's an in and out kind of process, as well as accelerating access to those vectors. And caching using Dragonfly is critical for that. So some real high power use cases are getting a lot of value from using Dragonfly for their vector capabilities. So definitely, depending on what you're looking to do, this is a key one. And it's very easy to integrate and scale. And depending on how fast or whether you want to prepare for a large scale out, this is something to consider when you're doing your technical bake-off.
Okay, so I believe, John, you mentioned several times hybrid search, and possibly people start questioning why should they need hybrid search, because we just told them that all ChatGPT does is vector search. However, there is a problem with pure vector search. And the problem is that pure vector search is not a precise search. As we saw, we are living in a 3D or ND world, and vector search is searching for neighbors, searching for stuff, for vectors, for information that is close but not precise. So vector search sometimes is not enough. Where, for example, you need precision in some of your decision, when you have just a huge data volumes and you cannot perform the search on, million records, because for each record you have to compare. For example, if you have 100 dimensions in your vector, for each record that you compare, you need to calculate 100 times. You need to compare 100 numbers. So in these examples, and let me give you a defined example. Let's say that I'm coming to visit you in London, John, and I need to book a hotel. And I want to book a hotel, that faces east, that is near a river, and the room has 3 beds because I need 3 beds. Possibly what I'm hitting is a part of the space that doesn't have a lot of results. And since it's a proximity search, the result could show me a lot of hotels that are rooms that are facing south and are near a river, but none of them could have the 3 beds that I requested. So this is why hybrid search is important. It is a way to allow you to search both in the vector space, but also perform filtering that is on kind of the columns, on the information that you find way more relevant for your search. And providing that hybrid search at scale is kind of a different beast than providing just vector search. So, sorry, with hybrid search, what we can do is mix traditional filtering and vector search. And guess what? Doing this kind of mixed filters is basically everything that traditional databases have been good at doing for years. Every time you look in, for example, Postgres or OpenSearch for, I want to have number of beds greater than 3 and then something else. This is what traditional databases have been optimized for years. And providing hybrid search on top of this traditional databases allow you to make search which is more precise, but also allows you to have what is called cardinality reduction. Instead of trying to navigate a space which is huge with millions of results, by pre-filtering the results, you actually start comparing only a smaller number of solutions. If we go back to the examples before, you don't start with all the hotels in London and then perform vector search, but you start with all the hotels in London, then, for example, have a room with 3 beds available on that specific night. So you can understand that the cardinality, the amount of data that you're comparing, is much lower. And it gives you a way to optimize also how you store the data for this kind of mixed queries. If you go back to traditional concept in the database like partitioning or indexing, you can use standard indexing to achieve way great performance with traditional approaches, with traditional databases. So let's check an example of how we can use one of the tools in a GenAI type of workload. And what we are using here is a retail use case with a semantic product search. So let's understand the 2 flows that we have here. Let's start with the flow on the right of the screen. Every time you create a new product, because maybe you are selling products on the internet, you are an Amazon 2.0, every time you create a product, what you have is you insert the product into the catalog, and that will automatically talk with, for example, the AI layer. Could be OpenAI, could be Gemini, could be something from Amazon, could be something open source, and create the embedding. That embedding will be stored in Ivan for Postgres along with all the other product information. So going to the flow on the left, every time a user logs in your app or your website, looks for, I want a pair of shoes that is green and, for example, is in stock in a shop less than 3 kilometers far from me, it can use both the embeddings and the start-down columns to perform an accurate search and give you all the products with the characteristics that you want, and also all the little details that are very important to you, like having the shoes in stock in a shop that is less than 3 kilometers far from me. So this is the powerful process of using a unique traditional database, because that Postgres will be there for your operational needs, but also for your vector search needs. So if you want to know more, we have a new page on the Ivan website, which talks about vector database. And let me also pop up the same information in here. No, I don't have it then. Okay. So you can go to that page. It talks all about our amazing vector capabilities. It goes a little bit more in detail on each of the technologies that we talk about. And if you have more questions, just talk to us and we will be happy to support any of your questions.
There's a quick question in there from Aquib. Extra info stored with the vector, how does it look like? It looks like the normal, however your data is stored within that relational, for in this example, PG relational database. So tables, rows, normal, like your standard kind of schema and data storage for a Postgres database, alongside then the additional vectors that are managed and searched through the pgvector index. And just for those, the embedding is the you create an embedding that is a vector. That's the vector reference.
Basically, you have all the standard goodies of a relational database in case of Postgres, or a document database in case of OpenSearch. But then you will have an additional column that stores your vectors. It's basically that simple. Next, So I want to close with a little bit of, we talk about vector database. I want to extend the horizon, because most of the time, vector database is just a part of an AI solution. And at Ivan, we provide a little bit more than just vector databases. At Ivan, we provide a data and AI platform, which can satisfy a lot of your needs in the terms of data and also AI. So what can Ivan do for AI? It can do 3 things. We do not huge things, a good number of things, but we do them really well. We do the 3 things for AI workloads. The first one is what we talk about, is the bottom one, vector search. Then we do real-time data for AI and AI optimized databases. So let's have a look at those. So the first one is vector backend for your applications. If you do RAG, retrieve augmented generation, this is a common use case of storing and retrieving vectors. Is all the use cases that we have been talking so far. The second one is this real-time governed data for your AI. What is this about? Well, let me say that if you're spending good amount of money and time into building generative AI or AI kind of product, the last thing that you want is, for example, a chatbot that you fine-tuned in order to talk like you, to use the same language, the same way of replying to your customers, but that, at the end of the day, provides wrong data to the customer itself. Possibly because, it suggests the same shoes that are no longer in stock. What you want is a way to provide to AI data which is accurate, is secure, and is in near real time. And this can be achieved with Ivan, with tools like Ivan for Apache Kafka, that allows to take the data from your operational data stores and bring that to the, for example, vector database or traditional database with vector capabilities that is serving AI. And you can do a lot of transformations on the fly. For example, you can empower ClickHouse in order to transform the data and remove PII data from your operational source into and before feeding AI. So the real-time component is critical because you cannot be late. You cannot give away suggestions with your generative AI applications. You cannot give away wrong suggestions with your generative AI application. The last bit is, what can we do inside the tooling that we have to give you a better experience? So in October, November, Ivan acquired a company called EverSQL. EverSQL is a leader in the database optimization space. It is a leader that has been used already by more than 2 million developers or professionals in order to optimize their query. And what we did is we embedded EverSQL in Ivan, and now we have a product called Ivan AI Database Optimizer. This database optimizer continuously monitor an Ivan for Postgres or Ivan for MySQL in the future database and provides suggestions on how you can improve the performance, suggesting you indexing to add or in the future to remove, and also suggesting you how you should change your SQL to achieve better performance. This is a game changer because it allows you to utilize your resource way better, to control your cost way better. So it allows you to do your work in a more cost-effective, less stressful, and more productive way.
Just to dive in, like one of the other advantages of us building this in the platform is more and more customers have moved to the cloud. They're increasing the fleet of databases they're looking after. And so I come from a support background. Troubleshooting a poorly performing database when fewer people are looking after more and more databases becomes really difficult. And the sooner you can get a database back to a performance state, either because you've tweaked the queries to make the workload more effective, or you've added indexes that were missing, or removed indexes that you weren't using, the better the ROI for your business. So we've seen a lot of really positive impact to our customers and their customers because they've been able to manage a bigger fleet of databases and a more complex infrastructure because we help them with their optimizations.
Indeed. Something that you don't want to do is to go over the logs of your 200 databases to find out what's wrong. If only there was a tool like the Database Optimizer that could send all this information and suggestion to you, it would be way, way easier. So I want to leave before the Q&A with a message that you can start on Ivan, exploring all our vector capabilities, exploring all our platform, including streaming use cases, including saving use cases. If you need observability on top of your database as well, you have plenty of solutions with us, and you can start for free by scanning this QR code. And now I found also the button that allows me to create a pop-up that you can check and scan as well. So now I would like to open the floor for if there are any questions. Please feel free to write them down in the chat. If you have any specific questions regarding vector database or anything that we talked so far in this webinar, just share it with us, and we will be happy to reply to them. And while we wait, I wonder if we can if we can ask ChatGPT what they think about Arsenal winning the league.
Don't.
It's a touchy topic, and I like the fact that I don't display anywhere the team that I'm supporting for.
I should get a better background.
Perfect. I don't see any questions. Please keep in touch with us if you have things that you want to share or further question that you didn't have time to share today. It was a pleasure being here with you, and thanks, John, for sharing all the details about our vector offering.
Perfect. Absolute pleasure. Again, happy to speak to anyone who wants to come and have a chat. And anyone who's heading to Big Data London, we'll see you there.
Thank you very much, and bye-bye.